Hi there, welcome to GeeklyEDU Math. In this video, we briefly explore exponential functions, taking a look at their interesting features, and we're also going to be looking at sketching an exponential function. So here we have the general formula of an exponential function given by y is equal to a multiplied by b to the power of x minus p plus q. Now we're going to be looking at the natural exponential function with base e. Now we've got three parameters there as highlighted for us. We've got a, p, and q, and we want to know what do these stand for? What do these represent? Now the a tells us about the stretch from the parent function e to the power of x. The p gives us a horizontal shift. Now if it's positive p, we have a horizontal shift to the left. Now you might actually think since it's positive, it must go to the right, so it's actually opposite direction, and then negative p, it's a horizontal shift to the right. Now q tells us of a vertical shift. Positive q, well, that's just a vertical shift up, and negative q is a vertical shift down. Right, and what's also interesting that's coming out to the fore with this is that the value of q, y is equal to positive or negative q, gives us the horizontal asymptote equation of this function. So those are the three parameters that are of interest here. And so here we are required to sketch the following exponential function showing intercepts as well as the asymptotes, and we need to also state the domain and range of the function. So we're given the function of f of x is equal to 2 to the power or e to the power x minus 3 minus 1, while the f, we can just replace that with y is just given by 2 exponential x minus 3 minus 1. So what we might like to work out or calculate first is the x-intercept, where our function cuts the x-axis, and we set y equal to 0 to work that out. And so now we'll be having 0, which is y is equal to 2 exponent x minus 3 minus 1. So now we just need to solve for x here. Bring the negative 1 over, so we have 1 is equal to 2 exponent x minus 3. Divide by the 2 on both sides. So you have exponent x minus 3 is equal to a half, and then you're going to find the natural logarithm, ln both sides, to get rid of the exponent there. So now x minus 3, which is the result, is equal to ln a half. Therefore, the x value is given by ln of a half minus or add 3, since we're taking the negative 3 over. And what is that going to give us? Well, that you can punch in your calculator and see what value do you get there. So I get a 2.31, or rather let's go to 3 decimal places. 2.307 is what I get. So 2.307 is our coordinate for the x-intercept. Now let's calculate the y-intercept, and how do we find that? Well, we set x is equal to 0. So here we have y is equal to 2 exponent to the power of 0 minus 3 is equal, or rather minus 1. Therefore y is equal to, so one can then just punch that out in our calculator. 2 exponent to the power of negative 3, negative 1, we find a minus 0.90. And so the 0.0 and minus 0.90 is our y-intercept. So let's take a look at those highlighted in yellow, green, and blue. Remember, the yellow gives us the stretch, green, horizontal shift, negative 3. So where will it go to? 3 places to the right, and -1 tells you it goes 1 place down. And so if we take a look at the sketch, this is how the sketch looks like. The red sketch is our function of f. The green is the parent function, which is y is equal to exponent to the power of x. Now you can see what happened. It moved 3 places to the right and 1 place down. And we can see the coordinates of the intercepts there. Now the question went on further to say we must find the domain and range of these functions. So domain refers to the x values that we use. Now if you take a look at the red value or the red function, it's defined for all the x values. Therefore x is an element of real numbers, or you can write it as from -infinity to infinity. And then taking a look at the range of the function, it's where the function is valued on the y-axis. So it's starting all the way from -1 up to infinity. So we have here that y must be greater than -1, or you could say y must be from -1 to infinity. That's another way of representing it. So that's the domain and range of this function. So yes, that was a brief look at the exponential functions. Hopefully you enjoyed this. That's all for now on exponential functions. Briefly, I do encourage you to please subscribe to GeeklyEDU to watch many more of other videos of other interesting topics which you might be interested in. Thanks so much.